Hey everybody, welcome to another Probably Private. I'm Catherine Jarmal, and today we're going to talk about text summarization. Now you might be like, why would I need text summarization for my local AI? But probably if you've been using a local AI for a while, you might notice it's hard to keep track of conversations. It's hard to keep track of all the texts that you've already worked with. Maybe you're using a combination of local AI and paid AI, so cloud vendor-based AI, and you're having trouble managing your tokens and your context bloat. All of these things are good reasons to learn how to summarize text, especially because I don't know if you've noticed, but I've noticed in working with my own local AI that especially for LLMs, the amount of text that newer models put out is just huge. I mean, sometimes I don't even want to read it, even though I should probably read it, right? So what we're going to do today is I'm going to show you 3 different strategies for summarizing text. We're going to go from kind of simple to different types of advanced, and then you can choose which one works best for what it is that you're trying to do. Okay, so we're jumping into the Jupyter. This is part of the getting started section of the repo that I'll share in the description. So hopefully you can get it running on your computer as well so that you can follow along. I also have some additional reading links if you want to take a look at maybe some other options. So the first strategy that we're going to use is we're going to do something called TextRank with a library called Spacey and then another library called PyTextRank. Now, you've heard me talk about Spacey before. I'm a big fan of their work. They're also based here in Berlin. They're open source NLP tools, including stuff like this, so text summarization. And TextRank there's a link here with some diagrams, but I want you to think of TextRank as, remember we were talking in that video about different ways to do semantic search about PageRank from Google, and also about creating kind of graphs, knowledge graphs and things like this, and then trying to pull out from the knowledge graph what's important here, what's not, or from PageRank, which pages are important, best search results, and which ones aren't. Well, I want you to think of TextRank as that on a document level. And basically, that's in a certain way what it does. It tries to create all of the different concepts as different entities in this graph. And then it tries to say, okay, what's the summary? What's the kind of most average way out of these numerous items in the graph for us to describe this text? And we'll take a look at how it works. So if you don't already have Spacey installed, you're going to have to install that. You're going to also need to download the English vectors and install PyTextRank, which I already have installed. And here I'm just using Wikipedia as an example. This is just a small Python library that already can go scrape articles on Wikipedia, or actually it uses the API to get summaries. It doesn't scrape, but we're going to then import Spacey. We're going to load it with the English. So again, if you're working with documents in another language, make sure that you load a different one. We're going to import Wikipedia, and we're going to go through particle physics. So I end up working with a lot of physicists because a lot of people that ended up in machine learning are physicists. I did not have a good start in physics because the teacher was a substitute teacher in high school. And so, yeah, let's just say I had a very challenging first introduction to physics, but I've learned to kind of get interested in it. So let's look at particle physics. Not necessarily my strength, but something I think would be curious to learn more about. And here's the whole page, right? Now, I could read all of this, yeah, but I could also use PyTextRank to summarize it. So what we're going to do, we're going to import PyTextRank. We're going to add the pipeline TextRank. And now we have this pipeline. This is a spacey pipeline. And we have our document loaded in that pipeline. Okay, so we could go through and we could see already, because we've used this text rank, the different ranking of the different phrases, right? So how, again, we'd like to think of it, how central is this to the entire document? And we can break down the sentence boundaries, and we can choose here a rank cutoff. So I've chose here 0.08. You can go much higher. So you can look here, 0.08. You could choose 0.09, right? And depending on your document, you might, of course, have different scores. So I've just chose a rank cutoff. Again, experiment for your documents, or maybe choose a variety of cutoffs and then decide when you're done with this exercise kind of how you want the script to auto decide. And that rank, again, is essentially a variation of thinking through how, again, average or central is this concept. Here we can see we have everything from, 6 words to, I'm certain there's at least one word, right? So it's Wikipedia. So sometimes these markdown characters come in. And then we have, because we haven't normalized for spelling or for capitalization, we also probably have some repeats, right? Particle accelerators with capital, without. If you really care, like if you're using this in some sort of production setup, I would bother to go through and think through, do we want to keep capitalization? Do we want to leave it? What do we want to do? But because what I'm using this for is just local AI to summarize something and then move on with life, right? I'm just going to do essentially the least amount of work that I can do. And then we're going to go through all of the phrases in the document. If it's below our cutoff, we're just going to go on to the next one. Then for this unit vector list that I've started, we're going to append the rank. And then for each chunk, we're going to add that chunk, right? So let's run this. We can see our unit vector now has a bunch of ranks. That's what we expected. Now, essentially, what we've done is we've taken the ranks in the entire document, and then we've normalized them for the ranks just from the ones that we like. And then by doing that, we now can sort the sentences by how they relate to these terms that we have. So these, again, are going to be 1 word, 2 word, 3 words that are now normalized with each other, the most important phrases. And now we're going to go through the sentences, and we're going to try to say which sentences, based on these phrases and their importance to each other, which sentences are kind of the most median, the most average of what we're trying to do. And by doing so, then we have our sentence rankings now out of, again, all. So going back to all the sentences. And then we're going to use some nice Python item getter to essentially limit us to 4. You could do 5, you could do 7, you could do 10 sentences here. And we're going to go through those sentences and we're going to take the best. And so according to PyTextRank, and again, the choices we've made about these different parameters, we have subatomic particles, modern particle physics. Research is focused on subatomic particles, yada, 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 yada. Particle physics or high energy physics is the study. So then we can see, like, it's decided modern particle physics research to highlight first, then maybe a more traditional summary, and then experimental particle physics. So what we've done here is, again, just some Python, some pretty simple math, right? So the squared sum of the unit vector phrase, right? The unit vector of that particular phrase within the sentence, right? So this is very, very simple math. This is not complex. This will run very fast. And what it's going to do is, as we've seen here, it's going to take sentences directly from the text that you have and try to sort them in a way where they show what is the most important concepts of that article. So why or when to use PyTextRank? I think when you definitely don't want to change the language used. So this might be important if, let's say, you work in a field like legal technology, or you're a teacher and you don't want rewording of anything. I would summarize things with PyTextRank first, because it's not going to reword anything. It's literally going to find the sentences that are most important and sort them for you. And B, I would use it when you don't want to use any tokens and, you don't want to worry about token spend or having a GPU or anything like this. So this can run just fine on the tiniest of machines. I mean, you need something big enough to run spacey, but that won't be by any means big like an LLM or something like this. And you could even, a cool design pattern that I'm experimenting with myself locally is taking a whole library of documents, using something like this to write little summaries, abstracts of the documents. And then when you're doing search and retrieval, like we talked about, then search and retrieval on the summaries rather than on the entire documents. So this is a way to kind of build a knowledge graph, so to speak, of your documents without always having to parse through the entire document. You could even set it on a cron. It could run overnight, or to do this, with very little lift. So most of this code I took from PyTextRank examples that I've linked above. So have a look, change it if you want, change the amount of sentences, change the rank value, which phrases you're going to select as being part of that unit vector. And then, yeah, just experiment. I'd love to know how it goes. Another thing that you could do is you could summarize using a local LLM, right? So this probably makes sense if you already have an LLM in your workflow, you already have a computer that runs LLM really easily, and we're going to send the prompt. We're going to ask it to summarize the following. I'm going to send it to Gemma 1B. So this is a fairly small model, but summarization, as we've just seen, is not necessarily the most challenging of tasks. So I would assume that smaller models do just fine. And what I've noticed is sometimes bigger models return much more text than what I want to read. So if I'm using summarization to reduce text, I would like to make sure that the text I give back is small enough. We have our summary, and here we can already see the summary is much bigger, right? So I could tinker with this and say, please, please, please make it even smaller so you can play with this, right? I'm not going to do it right now because I'm certain that you know enough about prompting to work on the prompt and improve it. But we can already see we have essentially here a bit more than what I would have wanted. So that's going to be, in my opinion, the biggest challenge with LLMs is avoiding hallucination and actually being brief with summarization. And this is because, let's be real, you pay per token. People tend to like long responses. That combination does not incentivize most LLM providers to make something that is succinct. Okay. And so we run into the same problem that we ran into, which is we need to summarize our summarization, which is not, for me, a good workflow. So now moving to more advanced mode thinking, there are specifically models trained for summarization. There's a bunch of cool ones. I just chose one that I've known about because it's been out for a few years, but I would have a look around always on Hugging Face, read through, look who has the best summarization model. Summarization is a category on Hugging Face, so you can look it up. play around with a few, decide what works best. And especially if, let's say, you're working with very specific types of text, or you're working in a non-English language or mixed language setting, what I would do is I would look through and see what are the scores on different languages, what data sets were they trained on, and make an evaluation yourself. Is this going to be good or not? So what we're going to do is we're going to do this over on my GPU machine because this is a bigger model, and I'm afraid that between the video recording and my MacBook here that it's not work if we run it here. But let's go through the code really quickly. I'm going to use the transformers library from Hugging Face. I'm going to pull in this model, Google Pegasus XSum. XSum stands for a certain type of models that was trained for this. It's, again, a transformer style, but it's for extreme summarization. So there's many XSum models. Take a look around. But this is a Google one. Anyways, I'm going to set up a pipeline. I'm going to tokenize it because what you'll find is as you start to use more Hugging Face models, sometimes you're going to reach what they call a token max length, right? So the model that you're using has been done in a streamed chunking type of manner, and it's not going to be able to just take large text and do something with it. You're going to have to actually worry about chunking the text yourself and doing that. Luckily, Hugging Face already does this for you built into their tokenizer. So here I'm passing in the page context. I'm saying, please truncate the text. So use the max token. What's the max length? 512. Return the overflowing tokens. So basically build me something that I can iterate through to go 512 by 512. But in this case, I'm going to stride. That means I'm going to overlap 24 tokens between my chunks. It's going to make it a bit longer than it is, but I'm doing that to preserve some sort of context. Depending on your task, you might need to up this. So this is a fairly extreme choice, a low choice. Many people use 128 or something like this. So decide for you what's the stride that works. The sets mapping we don't need for our tasks. You might need for other tasks if you're sewing things back together. And then we're going to go through those chunks and we're basically going to say, summarize this. Okay, now summarize this. Now summarize this. At the end, hopefully we end up with something useful. So I'm going to show you now on my machine. I'm on my GPU machine. I'm going to import these. I'm going to run, again, this is literally just the code that you already have seen. So we see that I'm loaded on my CUDA. We see that some weights had to be auto-initialized. I don't really know why that is, but we're not going to worry about it because we're just going to see if this works. So here I have this. Oops, yeah. I need my page, and let's get our page going. Now we should be able to run this. Hold on, let me make the font bigger for you. So now I have my tokenizer, right? We already know what it's doing. And as the next step, we can actually run, oh, actually we need to initialize. So we have our chunks. We want to store our results in an empty list. And then we can essentially iterate through our chunks, right? So this is going to take a minute to run. And we can see our results. What is particle physics? Elementary particles, standard model, Higgs boson, standard model. So we can see probably these two could be combined. But again, if we're just using this to create essentially a summarization of a bunch of different documents, this has worked pretty well. And we see because it's an extreme summarizer, it literally will only do one sentence per chunk, which is great. If that's what we're really going for, is we want to summarize and limit and basically say, look, in this document, you can learn about these things. That could be a really cool workflow that we use. And again, we could just iterate through and essentially extract just the summary text, put this in a text file. So I hope you've had some fun learning about different ways to summarize. I hope that I've been able to show you a little bit of the different choices that you can make for summarization, from staying in kind of simple, easy, but also true to the text, to using an LLM, which might work for your workflow, to using a task-specific deep learning model. And each of these are going to have pros and cons, but I'm excited to hear from you. What are you using summarization for? Are you using it to reduce context bloat? Are you using it to index things? Are you using it for better search and retrieval? Are you using it just because you're tired of reading long LLM responses like me? I'd love to know more about that. And I'd be excited to hear if you try out any of these. How do they work for you? So I'll see you next week, where we're going to dive into more local AI.